Hello everybody and welcome to example 3. We're still looking at page 5 of the workbook here. And this is another example of a function that has two input variables and one output variable. Let's read this question together. So wind chill temperature is a temperature which tells you how cold it feels as a result of the combination of wind and temperature. We're going to let C equal f of w and t, notice three variables involved there, where C is the wind chill temperature that's associated with a wind speed of W miles per hour and an actual temperature of T degrees Fahrenheit. Okay, and one thing that's interesting about this function and the way that it's given to us is we don't have a formula for this function. This function is given in tabular form over here to the right, and that's a very common way that functions are presented in math and science. Okay, maybe just to talk about what this table is telling us, you might notice that there's a W and a T here, and because the W is on the left, that's meant to suggest that the W values are actually here, and the T values are up here in our table. Okay, we'll use this notation a lot. Okay, and then the third variable, the C, the wind chill temperature, those are the values that are actually in the table down here. Okay, those are C values. And we're going to try to use all of that to answer the questions that we're given here. Okay, so let's take a look at part A. They would like us to evaluate and interpret f of 20 and 5. Okay, notice that's asking us to do two things. To come up with a number, that's the evaluate part, but then also to explain it in words. What does it mean in the context of this problem? Okay, so to get started with this, what I always like to do is to ask myself, what are the variables that are involved here? Okay, so if we start with the 20, notice that that's going with the variable W up here. So that's a wind speed. And then the 5 goes with the variable T, which is an actual air temperature. Okay, that gets us started and tells us where to look in our table to answer this question. All right, so we would like to know what is the C value, the wind chill temperature, when W is 20 and T is 5, okay? So let's find W equals 20, that's sitting here, and then T equals 5 is sitting up here, and so the output that goes with this would be negative 15. That should be the output value, the answer to this question. All right, so let's write that down. F of 20 and 5 is negative 15, and that's a wind chill temperature, so it's going to have units of degrees, oh, not Celsius, Fahrenheit, sorry. Degrees Fahrenheit. Okay, so we have answered the evaluate part of the question. We have a number. What about the interpretation here? What does that mean in words, what we did? Okay, well, all we really need to do here is just to kind of explain the meaning of each of these three numbers. So starting with the 20, that's a wind speed, and 5 is an air temperature, so we might start our statement by saying something like, when the wind is blowing at 20 miles per hour, okay, and the air temperature is 5 degrees Fahrenheit. Okay, that's the start. And last number to explain is the negative 15. That's the wind chill temperature, so we're saying that the wind chill temperature is going to be negative 15 degrees Fahrenheit. Okay, there's our interpretation. And so it's basically saying that at this wind speed and air temperature of 5 degrees Fahrenheit, it's going to really feel like it's negative 15 degrees Fahrenheit. It's going to feel colder. If you've ever lived in a cold climate, you know that this wind chill factor is a real thing. Okay, now what about part B here? Okay, this is asking us a question with a little bit of a different twist to it. How fast does the wind need to blow for it to feel like negative 10 degrees Fahrenheit when the air temperature is really 5 degrees Fahrenheit? Okay, so to answer this question, it would help to kind of nail down what these numbers are. What variables do they represent? So for it to feel like negative 10 degrees Fahrenheit, that's a wind chill temperature. So that's a value of C. But the real temperature of 5 degrees Fahrenheit, that's going to be T, according to the way that our variables were given to us in the problem. Okay, so what we're being asked to find then essentially is the wind speed. All right, so if we put this in mathematical terms, it's like saying, can we solve the equation f of w and 5 equals -10? We'd like to know what wind speed makes that a true statement. All right, and so we can answer that question by going up to our table here. So let's see, this 5 is a value of t. Let's start there. Okay, we've been in that column of our table before. And in that column of the table, we're looking for a wind chill temperature of -10. So we'll kind of look down our column and notice right there is a -10. And so what we're interested in is the W value that goes with that. That would be this number right here, 10. Okay, so we figured out that W equals 10. And what does that mean? Well, that 10 is a wind speed, so that's giving us a wind speed in miles per hour. Okay, that's the necessary speed that we're talking about. Okay, and we're finished.